Yes, to the Professor Dr. Dolphy Gilpin as we continue with Ytterbium, atomic number 70 and atomic weight of 173 point something. Let's, as usual, find it here in our little partial periodic table here. We have YB 70, 173.14, something like that. We'll give a more precision account of the decimal elsewhere. YB 70 atomic number, atomic weight of 173.14, and below it is NO, probably nobelium, and it's in the lanthanide series, ytterbium. Okay, so let's continue here. Again, we have afternoon beef like zirconium. Ytterbium 70, 173.19, and we're continuing with chemical reactions. And what we have here is that 2 YB, which is 2 ytterbium solid, plus 6 water, yield now ytterbium hydroxide, aqueous, and 3 hydrogen. So here it is behaving like the alkaline earth metal and even the alkaline metal. They have reactions with metal and water to yield hydrogen and hydroxide. But this is ytterbium solid with 6 water. It's balanced equation now to give you ytterbium 3 oxide, hydroxide, and hydrogen, which is the gas. Note it reacts slowly in cold water and quickly in hot water. That's usually a general characteristic of metal with cold and hot water. Not in all cases. But here it is, some of them don't react in neither cold nor hot water. Note, it reacts slowly in cold water and quicker in hot water to form ytterbium 3 hydroxide. So it's a YbOH bracket 3. We call that ytterbium 3 hydroxide. In which I think the ytterbium would be using the plus 3 oxidation state. Ytterbium forms a compound with the halogen family, or the halogen family like fluorine, chlorine, and bromine and iodine. So ytterbium chloride is used as a catalyst in when it forms in 2 famous organic chemistry reactions, and like the Diels-Alder reaction and the aldol reaction. So those 2 organic reactions, the catalyst, ytterbium chloride, rather ytterbium trichloride is used as a catalyst. Now, ytterbium discovered in 1878 by Jean de Marignane. I don't want to spoil this the name. It's Jean for Jen. It's Jean or de, like a French thing. Marignane, Marignae, Marignae, and It was named after the famous town in Sweden called Ytterby, Ytterby. So this was a village in Sweden called Ytterby, and these two, Sean, the Marigan, discovered it in 1878. Note that the discovery date and the isolation date, when it was isolated, are two different dates. I think the discovery date is 1878, and the isolation date is 1929, when it was first prepared by double climb and double shoot. So yeah, there's a difference between the isolation and preparation and the discovery itself. And like I just said, it was named after that village in Sweden called Ytterby. Now, Ytterbium is a white, silvery, soft, ductile metal. It is attacked by strong acids and reacts slowly with air and water. So if you leave it in air and water, if you expose it to air and water, it will react with air and water. Most of these lanthanide series, when you expose it to air, reacts slowly and form a coat of some form of oxide or anti-corrosion sort of substance, and then this prevents further reaction. So that's a general thing from most of these lanthanide series metal. A very small amount of ytterbium metal was made in 1937 formed by eating potassium and ytterbium trichloride. It was only in 1953 that pure sample of ytterbium metal was obtained. So 1953 pure samples of this ytterbium metal was obtained. So there are many dates on these things. Of 1937, ytterbium metal was formed by eating potassium and ytterbium chloride. And in 1953, but I guess it wasn't pure at that time. They didn't purify it. But it was not until 1953 that the pure metal itself was obtained. Now continue the reaction of ytterbium. You have now all right, so we have three ytterbium reaction with halogen family, or the halogen group, which is that group there: fluorine, chlorine, bromine, iodine, acetane, and TS there, fluorine, bromine, chlorine, iodine, and those are the popular ones. The other two are not so popular. So you have 3 ytterbium plus fluorine, 3YB plus 3YBF2, which is ytterbium fluoride, will yield 2YBF3. So it's oxidized to the ytterbium trifluoride plus ytterbium, which is at high temperatures. And also, likewise, the rest of halogen, chlorine, bromine, and iodine will be the same thing. And all of them are white. This white silver ytterbium is formed. 3YbCl2 is oxidized now to YbCl3. So we're going from the dichloride to the trichloride, or the 2-chloride to the ytterbium 3-chloride, and then ytterbium is isolated, plus ytterbium. Also 3-ytterbium, yeah, Ytterbium, 3YbBr2 will yield 2YbBr3. So we're going from Br2 to Br3 plus ytterbium. And 3YbI2 will yield 2YbI3 plus ytterbium. So this is a way to isolate ytterbium using the halogens by oxidizing the dihalide to a trihalide. An halide, that's the name for the halogens. That would be like an adjective from the halogen. But halogen is almost like the adjective already. Halide would be the salt. Okay. So the general reaction is that 3YbX2 will yield 2YbX3 plus ytterbium, where X is equal to fluorine, chlorine, bromine, iodine, and usually intangible one, AT, acetine, and TS as well, probably. But those two are not normally tangible. We don't know if they are toxicity with handling those or the flammability with handling those, but we're sure of fluorine, bromine, chlorine, and iodine. The general reaction would be 3YbX, where X2 will be representing fluorine, chlorine, bromine, and iodine. That is F, Cl, Br, and I in the atomic element form. Now, other uses of ytterbium is used for fiber lasers. It provides a fixed wavelength output of about 1040 nanometers with tuning across the near infrared provided by optical parametric device. So it's application in fiber laser, ytterbium fiber lasers, which provide fixed wavelengths with an output of about 1000 approximately nanometers, 1040 nanometers here, with a tuning across the near infrared provided by an optical parametric device. So other reaction here of ytterbium, you have 4Yb plus 3 oxygen will give you 2Yb2O3, which is ytterbium 3 oxide. Once again, 4Yb, which is ytterbium metal, plus 3 oxygen molecules will give you 2Yb2O3, which is the ytterbium 3 oxide. And 2Yb plus 3 F2 gas, that is a Yb solid and fluorine gas, will give you 2YbF3 solid, which is Y. I think we went through these reactions around here. Yeah, we did went through them already. So no need to go over back these reactions with halogen families. Now reaction of ytterbium with acids, we have 2Yb solid plus moderate concentrated, moderate sulfuric acid here, aqueous, 3H2SO4, then will give you 2 Ytterbium 3 plus aqueous, 2 YB 3 plus 3 SO4 2 minus ions, and plus 3 hydrogen gas, 3 hydrogen molecules gas. So that is the reaction of ytterbium with sulfuric acid. To give you, this was in an ionic equation form, 2 ytterbium plus 3 plus, so I guess it will be ytterbium sulfate if you take it in the solvent form. But we have in it as an ionic equation, 3SO4 2 minus and 3 hydrogen molecule gas. So there we have an introduction to ytterbium, YB, and a quick and fast thing would be that summary: atomic number 70, atomic mass 173.19, founded in the village of Ytterby in Sweden, and its electronic configuration XC 4F14 6X2. 4F14 6X2. And for that we will conclude the introduction to ytterbium here. Another thing, we'll come back if we need to come back, and we'll next take up another element of the lanthanide series.